Awesome. Welcome everybody to our presentation on Kubernetes. Where is Kubernetes? What is Kubernetes? And why is Kubernetes? We're going to go over all of these and talk about how you would deploy an application, why you would deploy an application, and where you would deploy it on Kubernetes. So let's go ahead and get started. So, what is Kubernetes? So, Kubernetes has a bunch of different components. These build up together to make a highly interconnected system that allows for a large amount of data to be communicated for a large environment. We'll get into what that means. It's a lot of words, a lot of big words, but it really helps with environments where you might have thousands of the same applications running all across the world. So, Kubernetes, if you've ever used Docker, Kubernetes is built upon, it uses a container runtime called Containerd. I think there's another one that we were talking about, CRI-O, which is mainly used for cloud environments. But it's built upon Containerd, which is the same one that Docker is built upon. And if you've used Docker before, that is going to be a little bit of it's not super important, but I do recommend looking into it before you get into Kubernetes, because most Kubernetes, most of your Docker knowledge is going to help you move into Kubernetes. It's really important that you understand that, because Docker is sort of a foundation for Kubernetes. So the more official way to say it is Kubernetes is an open source technology that allows administrators to administer and manage applications in an automated fashion. So in human speak, this means that basically you can write code that automates your deployment of applications. Why is this important? Well, if you're deploying your website on a server, it's not that big of a deal. You can deploy your website, and if something goes wrong with it, it's not that big of a deal. You're one person, but it's also one application. When you're dealing with an application that you need, for example, like you'll need a server in America, maybe East and West. It's very common. You'll need a server in maybe China or Japan, somewhere else. That way, because if somebody is trying to connect from China and it's super slow, then you have a lot of problems. Reduces your brand. So you want to make sure that you can deploy this application to those areas. And when you have these applications, generally you don't just have one running on a server in China, one running on a server in America. You would have probably, if you're a big enough company to where having servers in other countries is important, you'll probably have hundreds, if not thousands, of instances running. This is why you want to have it running as code, because code is reproducible. So can take advantage of hundreds, if not thousands, of computers. I think the limit for the number of nodes for Kubernetes is like 10,000. Is it? I think it's 10,000. Yeah. And that may sound like a crazy number, but it is in fact not. There is actually a lot of stuff going on in the quantitative trading scene at the moment, where they need compute power across a significant amount of nodes. And when you're trying to deal with things where your workloads can change very, very quickly, you want to be able to spin up nodes super quickly. And this is where you get into not just multi-node environments, but multi-cluster environments, where you'll have clusters of 10,000 nodes, which is absolutely crazy. But this is what Kubernetes allows you to do. So let's talk about Docker a bit. I don't want to go super deep into it, because that Docker could be talked about in several presentations of its own, but we're focusing on Kubernetes. So Docker is sort of the base application that Kubernetes can run on. More specifically, the containerd runtime, which is sort of the underlying part of Docker. But you'll see in most Kubernetes installations that you'll do on your own, you'll install Docker first. Because Docker will install containerd, and then Kubernetes will run on top of that. So Docker runs applications locally, usually locally, and these images are meant to be ephemeral, which means if they shut down and you start them back up, they'll be in the same state. If you completely shut it down, remove it, move it to another system, and you start it back up, same state as before. So it's ephemeral. It doesn't like use the host system for anything. Completely separated and isolated. So you can deploy your application on Docker with Docker commands and Docker files. We will be looking at a Docker file, but obviously, like I said, I'd recommend looking at Docker on your own time at some point. So why is Kubernetes? What does Kubernetes solve? So let's look at some of the components of Kubernetes. So as we talked about, it's a platform that allows multiple computers to communicate over the internet. It could be the wider internet, it could be an intranet, it could be locally. It's pretty common, like the one we have at ACM, where we have 9 nodes all running together, well, mostly running. So they can run and they're very, very versatile and can run in many, many different environments. These don't even have to be running on the same type of host. You could have one host that's running Ubuntu, one that's running CentOS, one that's running Red Hat. If you really, really don't like what you do, really hate your life, then you could do that. But generally, you would install it on the same platform, because when you're trying to do something that's reproducible, you want to sort of have a good base, the same base across the board. So as we talked about, automates deployments of application on Docker or containerd again. And Kubernetes also handles DNS. So the actual communication between these pods, which pods are these containers. Pods is what the Kubernetes term for a container is handled through something called kubedns or core DNS. Which is another pod in and of itself that handles the DNS or routing of DNS. One thing that's really nice about Kubernetes is that if you deploy an application on node 2 and you make a request for that application on node 1, it automatically knows, hey, that application is on node 2, let's redirect the request to node 2. And as far as the user is concerned, there's nothing that changes. There's nothing they wouldn't be able to notice the difference. And then all of the application data is stored in a key value store. Traditionally, this is etcd, but can also be MySQL, MariaDB, can also be used, but traditionally it's etcd. It's built into Linux and it works really, really well across a cluster environment, and it tends to be what they use. What Kubernetes uses. Kubernetes determines the best node to deploy an application on based off of the criteria that's given in the deployment file, which we will be looking at. It determines sometimes you don't want it's very common for you to have sort of nodes that have a lot of power and nodes that have very little power, and you want to restrict these applications to nodes with less power. So you would put in there, say, I want an affinity for less powerful nodes. And this is handled by the kube scheduler. A scheduler will schedule applications onto these nodes. And there are many other different components that facilitate communication and ensure the functionality of the cluster. But those are sort of the important ones. I think I'll talk a little bit about kubelet in a bit, but that handles pretty much all of it. That's the most important things to focus on. The other thing I think will be API server, which handles the actual API calls to the cluster. But yes, these are the ones that really make Kubernetes Kubernetes. So you have an application that needs to be available, highly available. So this means that if a node goes down, you still want your application to be available. Traditionally, you would deploy your application on, like, you use some sort of daemon to deploy an application on your Linux system. And if that Linux system goes down, well, that application goes down. But with Kubernetes, you could easily just change the replica count, which is the number of replicas of this container that runs across the nodes. And the kube scheduler will handle which nodes, and it'll spread it out. So highly available means that it's highly available. So if one node goes down, then it's still available through another node. And the Kubernetes will automatically see, hey, this is down on this node. Let's move it to another available node. A lot of the times in modern environments, it'll need to be deployed through code. This allows you to use something like Jenkins or GitHub Actions or some other infrastructure management to deploy a CI/CD to sort of help deploy and manage your code and run it through tests and everything. So, where do we deploy Kubernetes? We know what it is. We know why we need it. Where do we deploy it? So Kubernetes can be deployed on pretty much any system that can run Docker. It comes in many, many different versions and flavors. As we talked about before, Kubernetes is open source. So since it's open source, there are a lot of different sort of, not spin-offs, but sort of rebranding and tools to help facilitate easier cluster management. So Minikube is a great one to start with. Minikube is installed as an application on your local computer. It sets up basically a one-node cluster that can deploy a Kubernetes application on your local system. Super nice, super great way to start to learn about Kubernetes. But it has some restrictions, some limitations. Obviously, since it's one node, if it goes down, then, well, you lose everything that's running onto it. It's only intended for development. You don't get full networking. You don't get, you can install an Ingress controller. We'll get into that in a minute, but it's not really meant to do that. It's not meant for production side applications. Now, if you're going to be deploying this on bare metal, you have the hardware. You could use, your base Kubernetes, which is it's the base Kubernetes. It's the raw form, but it's kind of a pain to set up. If you get your permissions wrong, if you get something installed wrong, something is weird on a platform, then sucks. Hopefully there's some documentation out there with somebody who has the same issue. But it's pretty complicated to go through. I've set up a couple of raw K8s before, and it's just not worth the time. So that's where Rke and K3s comes in. Rke actually runs all of the Kubernetes components in Docker. It requires Docker to be installed on all the systems, but it actually runs it all in Docker, which is super nice because, as I said, anything that runs Docker will be able to run Kubernetes. So I prefer Rke, but there's also K3s, which is basically a version of Kubernetes that's very, very, is significantly less resource intensive. So I had like a Raspberry Pi Kubernetes cluster. K3s requires significantly less resources, but it doesn't have as many nice features and is a little bit more crash prone from what I found. There's also cloud versions. You have AWS, Elastic Kubernetes Service, I believe, Azure Kubernetes Service, a GCP, Google Kubernetes Engine. Those are the most popular ones. Small differences, but they all function pretty much identically. Most of your files you'll be able to deploy on any Kubernetes, and they'll just work. You might have to make some small changes for cloud engines, so they know how to, so they have some special know-how for deploying it. But for the most part, they all will work identically. So let's look at how we would actually deploy an application. We want to deploy a website that is highly available and can be managed by code. So first, we would create a Docker container. Okay. This is what we would do at the very beginning. We would test this separately of the Kubernetes cluster. We have an example Docker file here. We would just pull from Node, create some directories, install the Node modules, copy over the data, expose port 3000, and run the command node and app.js. So if you're familiar with deploying an application, a Node application, this is fairly standard stuff. It's just in a Docker file. You would build the Docker file and test it and make sure it works locally. This would commonly be done through like a CI/CD infrastructure. You would have this Docker file, you would push it to your GitHub Actions, it would build everything, and upload it to your Docker Hub or private registry, and you'd be able to access it from there. So at that point, we've got an application that we want to deploy, but now we need to actually deploy it. So how do we physically deploy Kubernetes? Well, for this example, we'll be using 3 nodes with Rke. I think the example config that we're going to look at in a minute has a few more nodes. But 3 nodes with Rke. Rke allows for automating the deployment of Kubernetes. K3s and stuff can be automated too, as well as like all the other cloud providers. But as far as like local Kubernetes, the easiest way for deploying this automatically is with Rke. Nodes are required to have Docker and SSH keys installed. The SSH keys only have to be installed from the host that's executing the Rke config to the nodes that are actually running it. So you only need it one way. Those nodes don't need to connect back because after everything is set up on that node, Kubernetes will just communicate through their internal network. But you will need like a cluster level SSH key that can connect to all the nodes. So you would normally set up SSH keys across the cluster with a specified user, and you would install Docker, and that's pretty much everything you would need. So let's look at an Rke config. Let me pull it up here. Make sure I got the right one pulled up. All right. Let's make this a bit bigger for people like me who are blind. So, if you're not familiar with YAML, very, very basic. You have key value pairs. Yeah, that's pretty much all that you really need to know. If you can read up a little bit more about the technical, but YAML it can change depending on the application that you're looking at, but you'll sort of get used to reading it and knowing how to format things. Like things that start with a dash are usually lists. Pretty much everything I think is interpreted as a string. And these are sometimes they have special things like objects. I'm not exactly sure how you would call this, but it's very similar if you think about like if you look at JSON, you've also got sort of objects with key value pairs. You've also got lists. Very, very basic, but it can change depending on what you're doing it on. So we have nodes, and we have a list here. We have our address, In this example, it's Rke-1, Rke-2, Rke-3, and you would set up you give all your nodes here their SSH port. Sometimes, if you're running in a more complicated environment, you would want to give an internal address. So this would be like an IP address. I have had some issues where if you don't put that on like a complicated environment where you have multiple NICs, it'll break things. But in this example, I didn't need to. You would give your roles. So a control plane is a master. So this is what will have all of the API servers and have the scheduler. These are the main brains of the operation. Without these, your cluster won't work. Generally, you would have at least 3 masters or 3 control planes. For highly available applications, you would need at least 3, and they need to be odd. So 3, 5, 7, 9 is the way to go. Then you have etcd, which, as we talked about before, is how it stores the key value pairs. And every node that has an etcd role will be part of the etc cluster. So there's actually 2 clusters going on here. There's an etcd cluster and there's a Kubernetes cluster. And these control planes are also workers. Now, in a lot of environments, especially where you have tons and tons and tons of requests, you would want your masters to handle only sort of those requests and the scheduling. And you would have separate nodes that would handle worker requests, that would actually handle the applications. So worker nodes actually handle applications, actually run applications. If this was not here, if these did not have the worker role, then it would not run applications, or run containers or pods. You have an SSH key path, which defines where the key path is to sort of connect to those other hosts. You have your labels, as we talked about before. When you're running a big environment where some nodes have a lot of power and some nodes have less power, you would have labels. And these labels, for example, in here, I use like preference high, and master 2, I also use preference high, but I use on master 3 preference low, so for low priority applications. This is all auto-generated. You can actually auto-generate all of this by using Rke Config, and then giving a name. You would usually use cluster.yaml. Let me make sure that there's not one in here. Yep, so it asks you your cluster level SSH key path, the number of hosts, and then as you go through, it's like an automated loop that just goes through and asks you all the questions, and puts them in this nice configuration file. Now some of this is auto-generated. None of these are super important. Let's go through to the important stuff. So your network, I won't really be explaining different networks, but basically networks offer different ways of sort of managing how your pods communicate. In this example, we're using Canal. Some other ones, popular ones, are like Flannel or Weave. These are all sort of networking plugins that can run on Kubernetes. Won't get super deep into them, but that is something to take into consideration. Do a little bit of research on before when you're deploying it. Kubernetes version. There are a bunch of Kubernetes versions. They get updated basically on a yearly basis, I think. They're on a rotating cycle. Generally, you want to stay one version behind, which luckily RKE is usually one version behind. They're usually pretty stable. I believe it's Rke Config list versions --all. Yeah, lists all of the versions. So I'm using 1.20.11. No, I'm using 1.20.5. Looks like there's a 1.20.11, and there's also a 1.21.5, but 21 does have some issues. Ingress, we'll talk a little bit more about that, but Ingress basically is a way for ingress. So any data that's coming in from the outside, you would have a controller that handles ingress. There's a couple of popular ones, Nginx and Traffic. I usually stick with Nginx. It's very simple and it deploys really well, but Traffic has a lot of really cool features, especially if you've used like other Traffic products. Yeah, that is pretty much everything that's important in this. This is pretty much all auto-generated. The only things they'll ask you about is like network, which network plugin you want to use, and you might have to manually go in here and set the Kubernetes version and the Ingress provider. But the rest of this would be auto-generated for you. So yeah, this is a look at a cluster config file for Rke. And you would just run this. You would have this in the same directory. You would just do Rke up --config and then the name of the config file. And it would run all of that and get everything set up for you. So let's look at actually deploying the Kubernetes application. So we'll be looking at a deployment, a service, and an ingress. These are the basic things that you would need for an application, the absolute bare minimum. There are plenty of other different things you might need to add. For example, if you need storage, you'll need a PV or a PVC, a persistent volume or a persistent volume claim. And if you need, if you're trying to deploy like a big, some bigger applications that take advantage of some other features of Kubernetes, you might need to deploy like a stateful set or some other fancy networking plugin. But we will not be looking at that. We'll be looking at a very, very basic application. We're just deploying a website that's highly available. So, deployment defines how the application is deployed. The deployment file is sort of the connector for all of the different parts of a Kubernetes application. It tells you which container it's going to be using. It tells you which ports need to be open. It's very similar to if you're running a Docker command to run an application. It's basically, this is your main Docker command. And everything else, it defines some labels so you can reference them later and keep track of your applications. Define some namespaces, which are like really cool for, if you have 20 different applications running on a cluster, then you don't want like all of your applications to be together in one namespace. You want to keep everything in a separate namespace. And we'll look at how to look at different namespaces. But for example, if you had a web server, you would have the namespace be like website. And everything related to that website would be in that one namespace. So yeah. A service defines like how the network would interact with the pod. This has several different versions. We'll look at an actual service file. But this has defines a little bit about the networking. Networking in Kubernetes is pretty complicated. That's why we have two different things here for networking. The other one is an ingress. We talked about ingress a little bit already, but the ingress defines what routes that would go to the application. So generally, in the service file, you would say, okay, here's the IP that I want, or here's the port that I want to open for this application. The ingress would say, okay, here's the name, the DNS name, that if I receive, will go to this application. So let's look at some of these files. Let's look at a deployment file. So we're going to use my website as an example. Not a great example because currently it's not working, but it's an unrelated problem to Kubernetes. Um, so this, again, is a YAML file. As you can see, it looks a little bit different. The formatting is a little bit different. So that's why I said it's not too important to focus on it. But let's look at a couple of things. I just want to go over it. We have an API version. So when Kubernetes pushes updates to their API, and these files will change their API version depending on what resource they're trying to sort of define. So we're trying to define a resource of kind deployment, which is in the API apps v1. Generally, this will stay the same across all of your applications. All the deployments will be apps v1. All of these ingresses may be under some sort of networking extension API. Then we have some metadata. So we want to give our deployment a name, so website deployment. We have our namespace, which is website. And so we have a label, which is app and website. So this is if we wanted to go and grab all of our deployments with the label, with a label that is app, website. So we could have like app. A lot of times you'll have like app and maybe like backend or API or storage or something like that. But this is website, so we know this is the front end. Maybe you'll have like front end as the app, but it's an easy way to like categorize your deployments. And then we define our actual spec, our specifications. We have our replica, number of desired pods, and the kube scheduler will look at the replicas and determine where to put it. But we are saying we want 2 of these to be running at all times. Selector and match labels, app, website. This basically just tells the spec, hey, we're referencing this website, as well as the template. We'll also be looking, just telling Kubernetes that we're still referencing the app website. This is the important part. These are the specification for the container. So we have in here containers. We have a name for the container. This is not the actual name of the image. And then we have the image here. In this example, I'm using a private registry, but as we were looking at before, you would have like Docker Hub or a private registry, another private registry that you would have that would be in here and tell you where to find the image. You have your ports, which is the ports need to be open. So it's a web server. So we need to have port 80 open to be able to access that web server. Now, the Ingress will handle like SSL. So if you know anything about web servers, you might be wondering, well, why isn't 443 open? Normally, in Kubernetes, you would have your HTTP port open. You would not have SSL on the application itself. You would have SSL coming in to the Ingress. The Ingress would terminate the SSL and then send it over HTTP because everything inside the cluster is going to be secure. So we're just securing the communication from the user to the cluster. So generally your port would not have like HTTPS open from this, but you can if you want to. If you want to manage your own certificates and stuff separately for each application, if that's your prerogative. So let's look at a service. Services are a little bit simpler. Again, API version v1, it's a kind of service. Let's tell it what we're trying to access. We're trying to access our website with a label of app that is a website. And we tell Kubernetes the specifications. We tell it which port. We have port 80. Our target port is 80. These are generally going to be the same, but they're both required. I think target port and port, I think the main difference is the actual, it's been a while. You generally will keep these the same, but I believe it's when it's sending data versus when it's supposed to be receiving data, I believe. Maybe somebody can confirm on that. But if you have these different, that usually means that you'll have an application that would like send data and receive data on different ports, which is kind of weird. Tell the protocol, TCP, it's pretty much always going to be TCP, unless you have an application that uses UDP. And then in here, we have a node port. There are plenty of different, you can look at plenty of sample service files that go over different ways of defining these services, but most of the time you're going to see either cluster IP, which means that it will get a IP address inside the cluster, and it will not have any way of accessing from the outside without an ingress. Otherwise, if you want it to be accessible on a special port, you can use a node port. Now, node ports are not a catch-all. They're a good way if you have a lot of applications and you want to open a port for that application and you want something on the outside to be handling the traffic to that port. Because you can't just say node port 80. Node ports have to be between port 30,000 and 40,000, I believe. It might be a little bit bigger of a range, but it has to be between 30 and 40,000, somewhere in that range. It cannot be below that, cannot be above that. Again, our selector, app, website, and we have a type of node port. If you didn't want another port to be opened, you would just say like type cluster IP, and you would delete this node port, and you would get an internal cluster IP. And then the last thing, let's look at an ingress. So again, see, we have a little bit more complicated API version, but don't worry about it too much. We have an ingress kind, which is inside of the networking.kh.io/v1 API version. A lot of this stuff you'll get from like the documentation off of Kubernetes website, which is actually pretty good. We have some metadata, again, tells it which namespace it's going to be in, tells it the name of the ingress. But here we have a couple of annotations, which are ways to communicate special parameters to these controllers. So we have an ingress controller. We actually say, hey, we're using the ingress controller Nginx. And we also want to tell Nginx, we see that it has a special API parameter here, or a special parameter here that tells the API that we want to redirect to SSL. This will automatically redirect to SSL. The application will not be available without SSL. So it sets up a redirect. And then I automatically deploy certificates on my applications. So I tell it here that the issuer for certificates is my CA issuer. So this is how you would define some options that are sort of specific to the controller. Again, we have a specification. We have some rules where the host is the host name. And the backend is going to be a service named website service. And as you saw in our service file, website service is the name. On port 80, the path is /, so it's going to be the root. So anytime you go to www.christianbingman.com, and then prefix, since we're not actually going to be handling any paths after that. And then we also tell it the TLS name that we want to generate a certificate for and the secret to put it into. This generates basically your certificate and your private and public certificate key, certificate and key, and puts it into a secret, and then tells Nginx or whatever your ingress provider is, hey, here's the secrets for this, here's how you're going to encrypt it. And this is all auto-generated. So whenever I'm defining a new application, I pretty much just copy and paste all of these. Because as you can see, very few things actually need to be changed. Usually the port here, the service name, and the site need to be changed. But the rest of this don't really need to be changed. So a lot of this is pretty much copy-paste. Now it can get pretty complicated if you have like a bunch of volumes and stuff added for storage, but this is very, very basic, very easy to get into, and is reproducible, which is the nice thing. So you just copy this, copy and paste it, and create another deployment for another application. It's awesome. We looked at a deployment, a service, and an ingress. Let's look at actually deploying it. So Kubernetes uses something called kubectl. Kubectl, some people pronounce it kubectl. I just pronounce it kubectl, even though that's cuter. Kubectl allows you to interact with the API. So Kubernetes has an API, and when you want to interact with this, you can make actual like HTTP networking requests, but unless you're trying to create an application that needs to do like a low-level API request, you would generally just use kubectl. This uses a kube config. It's in your home directory, .kube/config is the default. You'll want to pull this from Rke after you've created your cluster. You'll take that your config. And I believe if you're using Minikube, it automatically puts the kube config in the right place and sets the environment variable. So you have you can either put it in the .kube/config or set the environment variable to be the kube config. And this will tell it where to access this. And inside of there will be a certificate to verify your user. You can actually set up like massive like environments where you have different users and stuff. But the one that you'll be getting from Minikube is basically like a root user, has full access to the cluster. And for now, it's pretty much all you would need. And then you would use kubectl apply, and then -f for the file, and then you would use the file name, and it would apply the file. It would just basically execute that file on the Kubernetes server and sort of run the deployment. So you would apply all three of them. So you'd apply the deployment, the service, and the ingress. Very quickly, we can look at a kube config file. Let me pull one up for you. So here is a really old one. Is no longer in use. So in here, you see we have a cluster, tells it the API version. You see it's very, very similar to the deployment files. So we have an API version, we tell it it's a kind of config. It tells it the certificate authority data, because generally the certificate files that your cluster will be generating are going to be self-signed. And generally, even if you have your own certificate system, you wouldn't actually manage, Kubernetes manages its own certificates. You generally don't actually need to create your own Kubernetes certificates. It tells it the certificate for the certificate authority so that it can verify the secure transmission. It tells it what server to connect to. The API server is always on 6443. The name of this, which is local, you can name it pretty much anything. This isn't required. Context. Contexts are super nice because if you have multiple different configs for multiple different clusters, you can have different contexts. And then we have our user, kube-admin-local. And then we have a client certificate and key file here, which is for communicating with the server. So, Once we've actually deployed it, we can use kubectl again, and we use the tac in and then the namespace. So if I wanted to check on the pods for, or the containers for my website, I would use like kubectl-in website, get pods, get services, get ingresses. And then if I want to actually look at like the Docker logs or the container logs, I would use logs and the name of the pod. And then if I wanted to get the Kubernetes description of the pod, I could use describe deployment, and this would give me like a description with a lot more details about that. This is more for some basic log checking if there's issues with Kubernetes. Like if there's an issue, like if a container isn't being scheduled properly. Like if there's not enough replicas coming up and you want to know why, you would check the deployment and make sure that everything is healthy there. But for logs relating to the container, you would use logs. But if you wanted to see logs relating to Kubernetes, you would use describe. So here's some examples. We have kubectl get pods, all namespaces. This would just give us a bunch of all of the pods running on the system. You can see that these are status running. Gives you the status running. That's usually pretty good. If you see like a ridiculous number of restarts, that might indicate something is wrong. Unless it's like a super long running application that restarts every once in a while, then it's fine. Container creating usually means that it's still downloading the container from the registry. Crash loop back off is a really annoying one that will pop up a lot of the times if your container crashes and it keeps crashing. So if it crashes multiple times, I think it's like, yeah, it's 3 times. If it crashes 3 times, then instead of using up a bunch of resources to keep redeploying a crashing container, it just, instead of doing it every like 30 seconds or something like that, it does it every like 5 minutes. So that I don't know if those times are exact.
Exponential backoff.
Say again?
It's an exponential backoff, so like
Exponential backoff.
Yeah.
Oh, so it increases.
So it increases as you start failing.
Oh, okay. Okay, I didn't know that. Good to know. That's probably a good thing that I don't know that. But yeah, so if you see a crash loop back off, that is usually an issue with the actual container. So you would check the logs on the container. So we can look at, then we would be able to look at the services. So we would use like kubectl-in, the namespace, get services, or SVC is a shorthand for it. And then we would see like website-service, we would get a cluster IP. Even if you say, I don't want a cluster IP, everything gets a cluster IP. It's just like if you, start a VM or something or connect a computer, it's going to get an IP address even if you don't request one. You always get an IP address, but it doesn't always get an external IP. It doesn't always get ports. So, So this would be the port they would be communicating over. So we would have like website, we would have a random cluster IP. We wouldn't have an external IP because we're having an ingress that handles that. And we would have port 80. And then we would have an ingress. So the ingress would have the name of the ingress, whatever we're connecting over. So in this case, it would be like www.christianbingman.com. The address, and so the address is for cloud environments to get the actual IP address, the public IP address. Normally, in a self-hosted environment, you would not have like a public address there. And then your ports would generally be 80/443. So it would be accepting requests on 80 HTTP and HTTPS. Quickly, I'm going to look at the actual deployment, describing the deployment. And you'll see that we have a lot of things copied here. This is sort of a more realistic, sort of way of deploying an application for a big website. So we see we have the namespace is default, but normally that default is the default namespace that everything goes into, but generally you would have a more specific namespace. You have your labels. So in our example, it was app equals website, but in this one, it's app equals hello node. Annotations, like as you saw in our Ingress, we had some custom annotations, but normally you wouldn't have like a bunch of custom annotations. So any custom annotations would show up there. Selector, same thing as label. They are not the same thing as label, but as far as that, how it's defined, same thing as label. Now replicas are important. As you can see, they're deploying 10,000. They have 10,000 desired replicas, 10,000 total, 10,000 updated. Why are updated and total separate? We'll get into that in just a second. We have 198 available and 9,802 unavailable, which usually means that it's still in the process of deploying. Because if there was errors, it would show up down here in the events log. Now, as I was hinting to before, why is there updated, total, and desired different? It's because it uses a rolling update strategy. So one thing that's really nice is that if you update a deployment, if you update a web server and you want to, usually once you update something like your site, you need to restart the web server to have those changes. So what Kubernetes allows you to do is if you have like multiple replicas, what it'll do is it'll shut down one replica, update that replica, start it, and then go to the next one. That's a rolling update. So it rolls through all of the replicas and updates them individually. That way there's always one running still.
So does that mean like someone will randomly get the old one and someone will randomly get the new one?
Correct. During that update time, some people may end up getting the old site. But most people would rather have somebody getting an old site for a couple milliseconds or a couple seconds than the site to go completely down for a couple seconds. So we see our pod template, which is basically just the same as what we had saw in the spec. You got your image, and there's an example of using Echo Server. It'll tell you the ports that are open, any environment variables that you've set, any mounts for like volumes, and any actual volumes that are mounted will be there. Some conditions, we see that progressing true, new replica set available. So this is basically saying, okay, it's currently working on getting to the amount of replicas that we're desiring. And the available is false because, well, we don't have all 10,000 available. And then, as you can see in our events, it basically just says scale replica set to 1, and then scale it to 10,000. That's just the deployment controller starting the deployment, and that's fairly standard on any deployment. But as I said, if you're having an issue with the deployment, there's two places you check. You check the actual pods and check their status, and then you can check their logs. And the other place is the describe the deployment. So describing the deployment will tell you issues with Kubernetes. Using logs will tell you issues with the actual containers. So now you have your website. I don't know if Andrew Hong uses Kubernetes. That would be pretty awesome. He's a great musician, but I don't think he's an IT. I don't know if he's an IT guy. So yeah, now you have your website available to millions or billions, and you know that it will be running. You know it's safe, will be safely running, especially if you run it in some sort of hosted environment like Google Cloud or Azure. So yeah, thanks for coming. There's an awesome little story. It's like an illustrated children's guide to Kubernetes. It's hilarious. You should check it out if you get a second. So yeah, does anybody have any questions?
Oh, yeah.
I know that was a lot. Yeah.
After doing all of this, where do I point my domain to?
You point your domain to any of the master nodes.
Any of them?
Generally, you would have some sort of DNS load balancer in front. They would say, okay, I connect on www.christianbingman.com, and this will go to RKE-1, RKE-2, RKE-3. So if RKE-1 fails and doesn't respond, it'll go to RKE-2, and then to RKE-3.
DNS load balancer fails.
Well, then you would ideally have your load balancer load balanced.
But like, there's always going to be a single point of failure, right? Because the domain can only point.
Theoretically, you would also have your single point of failure could also be like, well, yes and no. So you're going to have some sort of like DNS load balancer. It's going to point to your DNS server. And this DNS server, you'll likely have this DNS server. You'll have multiple, like you would have like multiple DNS server endpoints. So, yes.
But like in the domain registrar, the URL is going to.
You would point that to, like to that IP address of whatever the DNS server is, or whatever the load balancer is for the DNS server.
So like if that
And then
one
you
goes
could
out,
use
need to
like,
change that.
you could use like CARP or something,
Okay.
where you would have multiple servers listening on a same IP address in case one goes down. Any other questions? Anybody on the Discord have any questions? I know it was a lot, but Kubernetes is very big. Could easily spend 3 or 4 weeks just on Kubernetes, if not more. Yes, no, maybe so. This recording will be available. I will make the recording available, so you can go back and watch it if you want to. Okay. Yeah, Chase confirmed. You can define ports from 30,000 to 32,767. So not quite 40,000, but I don't know how many people are going to define 2,767 applications.
32767 is like 2 byte integer, right?
I'm not sure. Alrighty. Well, if nobody has any questions, feel free to ask on the SysAdmin channel. I'm sure me and Chase will respond. Is there anything you wanted to talk about, Chase, before we?
I guess if people have other topics that they want to learn about, feel free to post it, on Discord, and we can talk about it, or make a presentation even.
Yeah, so just in case you didn't hear, I'm not sure how well the mic works over there. So if anybody has any ideas or suggestions on some presentations that you would like to see, if you want us to go deeper into Kubernetes or like Docker or something, let us know. We can work on getting a presentation set up. As long as there's interest, we're definitely interested in making those. Just send either of us a PM or send it in the main chat. Awesome. Thank you everybody for coming. This has been my TED Talk. Like, comment, subscribe, ring the bell. Make sure you got your notifications turned on, because I'm sure there will be more. All right.